Now that we've talked about solutions and molarity, we can really get into what kinds of reactions I have. We've seen reactions and we learned how to balance them way back in the particles chapter, so we had some basic idea, but now we're going to sort of talk about them a little more. We now know about different kinds of compounds. We know about moles. We have different information, so we have more to bring to the table. We're going to start classifying reactions because there's just billions and billions of chemical reactions out there. And so we want to kind of categorize them so that we can deal with them in smaller quantities. There's a variety of ways that you can classify reactions. And in one way, you can focus on what are, which ions are reacting and how they're reacting. Because that's what we're going to do in this chapter. Mostly we're talking about aqueous reactions. We're going to have, we said that when you have ionic substances and you put them in water, if they dissolve, they dissociate. So I'm going to have ions. And these ions can then go on to do reaction chemistry. If I have a cation and an anion making a solid, so these are dissolved, dissociated ions, and then they meet and find something that's insoluble and make a ionic compound that's no longer soluble, it's going to fall out of solution. We call that a precipitation reaction. If I have an acid and a base, so acids produce protons and bases produce hydroxide ions, and they can then find each other and combine and make water, which is a liquid. This is a neutralization reaction. Essentially, at the core of it, I have an acid and a base. So the protons came from the acid and the hydroxide ions came from the base, neutralizing and making water. And then I have a class called redox reactions. And in this case, I'm transferring electrons. So I have an element that's going to become an ion. I have an ion that's going to turn back into an element by gaining or losing electrons. You have to have one of each. So one that's going to gain the electrons, one that's going to lose the electrons, and we can have redox reactions. So these are the three that we're going to classify by in this class, but there's a whole other ways to classify them. Another way to classify them isn't by what ions are reacting, but what in general is the mechanism, what's happening to the reactants. So this is very helpful if I ask you to predict products. So in other words, just like if I had a variety of shapes, I could classify them by color or by size or by shape. And so a yellow, big yellow circle would be able to fit into a variety of categories. Similarly, some double displacement and single displacement may also be, the double displacement may also be neutralization or precipitation reactions. The single displacement may also be a redox reaction because it's just a different categorization scheme. In a double displacement, or also called double replacement, they're the identical thing. I have two ionic compounds switching their anions. So in this case, the anion is B, and in this case, the anion is D. So over here I have A paired with B, but over here I have A paired with D. Over here I have C paired with D. Over here I have C paired with B. So the D and the B swapped places. You do have to make sure, and we'll talk about this, that when you do that, you still have to make compounds that are neutral. So you may have a change in subscripts along the way, but they're switching partners. And again, neutralization and precipitation reactions are often double displacement reactions also. Single displacement reactions are then, if you have an ionic compound and an element, and the element is going to become an ion and the ion is going to become an element. So what you end up seeing is the element is going to replace one of the components in the ionic compound. In this place, it's replacing the E. So the E is, A. The E is going to take the place of A. Right now, E is uncharged and neutral, and A is an ion, a cation in an ionic compound. E is going to replace A. A is then going to turn back into an element. So note that A is a cation, is positively charged. Over here, it's neutral. So it had to gain electrons. If E is a metal element and here it's neutral, in order to become a cation, it has to lose electrons. So there is a change of electrons going on as this process happens. But in terms of what's happening to the reactants, I see something's in a compound and now it's an element. and something is an element and now it's in a compound. So again, many redox reactions are also single displacement reactions. Again, there's a couple more types of reactions that are classified by what happens to reactions. We have combination or synthesis, where we're making one product. So I'm combining a bunch of stuff together into one big product. And a decomposition is the reverse. If I'm taking a compound and breaking it back down into its elements or smaller compounds of that big compound. So we may see these, you may hear them, you may see them in problems. We're not really going to focus on them in class, but I'm just kind of mentioning